Today we're going to discuss about some numerical problems related to the solid state chemistry. Okay, so the first question is, what are the numbers of octahedral and tetrahedral voids present in A? Number A is primitive or simple cubic unit cell. Okay, and number B is your body centered cubic unit cell, and C is the face centered cubic unit cell. Okay, so we're going to discuss one by one. So in the first we're going to mainly discuss about the primitive or simple cubic unit cell. Okay, so we know that in case of cubic unit cell, there are total 8 atoms are present in the corners of the cube. Okay, so again from this unit cell we don't get tetrahedral or octahedral voids, as it does not has the arrangement of the atoms which can actually give the tetrahedral or octahedral voids. Okay, so in case of primitive unit cell, the number of tetrahedral void is equal to 0, and the number of octahedral void is also 0. Okay, now let us discuss about the BCC, that means body centered cubic unit cell. Okay, so this is the figure of the body centered cubic unit cell, and here there are total 8 corners sphere or atoms, and additionally one constituent particle or sphere or atoms will be present at the body center of this unit, that means the cube. Okay, so actually we can draw, you see, total 6 octahedral voids as shown in this figure. Okay, but the thing is that if you only examine one octahedral void, suppose this one, okay, so actually this octahedral void will going to be shared between two unit cell. That means this octahedral void will be present one, and actually only half of this octahedral void will going to present inside this cube. Okay, that means we can say that all the 6 octahedral voids which are present in the each faces of this cube will going to be actually only half of them will going to present inside that cube. Okay, that means for all the 6 octahedral void, only half of them will going to be present inside that void. So that means total octahedral voids present in case of BCC is equal to 6. Total 6 octahedral voids are present, but only half contribution will come from that. That means only half of them will be present inside that cube, so we have to multiply by half. So 3 octahedral voids will be present. Okay, but if you again notice unit cell, then you cannot actually draw the tetrahedral. To actually draw tetrahedral, there must be some alternative atoms or sphere present in that cube, but there is no any alternative. Okay, alternative atoms will be present, or that means the atoms will not going to arrange themselves in alternative way, so we cannot have any tetrahedral voids. So the total tetrahedral voids, total number of tetrahedral voids, so here also number of is equal to 0. Understand? So this is about the BCC, and now coming to the FCC, which is already discussed in the previous class. Okay, actually in case of only FCC, we can use the formula, which is actually if the number of the constituent particle is n, or the atoms is n, then the number of octahedral void is also same, and the number of tetrahedral void is. So that means in case of FCC, we know that the let's suppose this one is FCC. Okay, in case of FCC, we know that the total number of atoms or the sphere you can say atoms, because from the previous class we already know that the total number of atoms in case of FCC is what, 8 into half, not half, 8, okay, 1 by 8, because it is coming from, this is actually contribution from the corner, okay, corner atoms, and plus total phase, how many phases are there, 12, 6, and at the center of each phases total 6 atoms will be present, but they will going to be we have to divide them by 2 because only half of them are inside that cube, okay. So it will be your what, 1 plus 3, that means 4. So that means the number of octahedral voids is equal to 4, and number of tetrahedral void is equal to 8. Understand? So in case of FCC we can only use this formula, but in case of primitive cubic unit cell, there will be no, we will not going to get any tetrahedral or octahedral voids. And in case of BCC only we can get some octahedral void, but this is actually some distorted octahedral voids, okay. So this is actually the number is 3, okay, and we will not going to get any tetrahedral voids in case of BCC, but in case of FCC, octahedral 4 and tetrahedral 8. Hope you understand this numerical problem. Now we are going to discuss about the second one, okay. Now coming to the second question. So second question is very interesting, okay. Actually in that question they will going to give you some informations, okay. So by using that information and some concept of the solid state chemistry, solid state chemistry, you can actually you have to find out the formula of a compound, or you can say that a solid, okay. So here in this question, actually the question is that an ionic solid is formed by 2 elements A and B, okay. Atoms of element B form the packing structure. If the element A occupy all the tetrahedral voids, then find the formula of the given solid, okay. So here the main technique is that the trick for this type of question is that always remember that if it is given that an element of the total, how many elements are given there, total 2 types of elements are given, like A and B, okay. So the trick or technique to solve this question is that the atoms or the elements which will going to form that packing structure will be the anion, okay. So that is a trick, because if it is for ionic solid, okay, or any solid compound, because the questions are only coming from the ionic solid mainly, okay. So the trick is that, so this is the very important, okay, then the atoms or element, okay, or element which form the packing structure, okay, packing structure, and that packing structure may be what, that packing structure may be FCC, okay, or they may give you like close cubic packing, or they can say that it may be HCP, okay. So any one of these, okay. So if the atom or elements which form the packing structure means the structure of the packing, 3D packing structure, then those elements will be your anion, okay. The atoms or elements which form the packing structure, and that actually atoms or elements will be actually your always anion. Why? Because we know that the anions are bigger in size than cations, okay, and that's why anion will going to form that packing structure. And always remember that the cations are always inside the the void, okay. And the second point is that these are the technique, okay, tricks to solve this type of question, okay. The first one is this one, and second one is what excuse me, the second one is the cations are always inside the void of the packing structure. Okay, structure. Actually, here we are writing here what packing structure. Actually, this is actually 3D packing structure. Okay, 3D, because here actually it should be 3D, because mainly we know that all real solids will exhibit 3D packing structure or 3D structure. Okay, so remember this point. Okay, 3D. So the cations are always inside the voids of the 3D packing structure, and the 3D packing structure will be formed by what? Anions. That means the packing structure will be formed by the anions, and in the voids, okay, always the cations will be present. Okay, and depending upon the size of the cation, if the size of the cations are, like, suppose it is bigger in size, okay, slightly, then it will going to occupy the octahedral voids. Okay, and third point is that if the size of the cation is bigger, okay, then they will, and the cation will occupy the void. Which void? Octahedral void. Octahedral void. Why octahedral void? Because the size of octahedral void is greater than the tetrahedral voids. Okay, so these 3 points are very important. And number 4, you can, if you want to write it, then you can write that if the size of the cation is smaller, then the cation will going to occupy the tetrahedral voids. Okay, so actually mainly these 3 are the important points which you have to use to solve this type of problem. Okay, now coming back to the question, which is 2. Here they said that the the ionic solid is formed by 2 elements. Okay, so you can always write, or you can solve the problem like this. Okay, you have to first write what is given. Okay, so the given is what? There are 2 elements. Okay, 2 elements. So these are given. Okay, given that 2 elements A and B form the packing from the solid. Okay, from the ionic solid. Clear? So now again they said that the B will going to, so the amongst these 2, that means between these 2, A and B actually are what? The elements. Okay, and between these 2, B will going to form what? The packing structure. So this again said that, and B forms actually the element B forms the packing structure. Okay, 3D packing structure. Okay, so that means what? From that previous trick, or that which is given to you, okay, that trick number 1 is what? Trick number 1 is that the atoms or elements which form the 3D packing structure will going to, actually they will be what? They will be your anion. That means B is what? That means that is B is anion. Understand? B is anion. So that means B will going to form what? B will going to form the packing structure. That means the number of B will go, that means B will going to, that means the number of B is equal to actually the number of sphere or atoms, or you can say sphere present in that packing structure. packing structure. Understand? Here the if you see this here you see here this is actually you see the 3D close packing. Okay, so this big actually sphere are what the anions, and the voids, these voids are in this void the cation will be present. Okay, the cation will be present in this void. Okay, so here you see this actually sphere, the number of sphere will be what, actually number of B, that means number of anion. Okay, understand? And it is given that the element A occupies, okay, because there are many A's, na? So occupy all the tetrahedral voids. So in exam, please don't write TD, okay, write full form, okay, don't write the short form. So occupy the tetrahedral voids, all the tetrahedral voids. Okay, so these are given things. So again we know that then here you see number, actually B is what, B is actually anion, and number of B is actually the number of atoms present or the sphere presence. Okay, understand? So that means, let's suppose the number of atoms is equal to n. Okay, that means number of B present in that close packing is equal to n, let's suppose. Okay, and here you see the element A occupy all the tetrahedral voids. Okay, so we know that if the number of atom present in a close packing is capital N, then the number of, and we know that here if the number of the atoms present in that close packing is capital N, then the number of octahedral void is same, but the tetrahedral void is double of the number of the atoms present in that close packing. So that means here you see element A occupy all the tetrahedral voids. All the tetrahedral voids means the all tetrahedral voids which are present in that packing. So we know that the that means that we know that the tetrahedral number of tetrahedral void is double of the atoms. That means it would be what, 2n. Understand? That means what we can say, we can say that the number of A present in that packing structure will be 2n. That means we can say that the number of A present in that packing structure, tell me what, packing structure will be what, 2n. Okay, because you see it will going to occupy all the tetrahedral voids, and the number of tetrahedral voids is actually twice n. So the element will be also twice n, because it will going to occupy all the tetrahedral voids, na? So it will be twice n. Now we have these informations. Okay, so let us suppose now, the formula of the formula is A B, but here let's suppose this will be, let's suppose this is n number of element B will going to present in that packing structure, so we have to write here n. Understand? But here how many A will be present in that close packing? It will be your twice n. Understand? So that means thus the formula of the compound, or you can say it, you can say that the solid is equal to actually what, A to B, because if you multiply 1 by n, then you're going to get A to B. Understand? So this is the molecular formula. So we can do this type of problem by using the techniques or tricks, three techniques. Okay, and also the concept, this concept. Okay, that means if the number of atoms present in that sphere is equal to n, then it will be the octahedral number will be same, but the tetrahedral void number will be the double of it. Okay, understand? So what we understood from the second problem. So we can do any problem, okay, any this type of problem by using the technique, which are the first, second, and three. Total 3 techniques are there, no? So according to the first technique, actually anions will going to from what, the close packing structure. Okay, anions will going to from the close packing structure. And the second one is that the cations are always inside the voids of the 3D packing. And third one is actually if it is size of this big, then it will be inside the octahedral, and if it is small, then it will be tetrahedral. So it is not so important, but 1 and 2 are important. Okay, and the second, this is the first concept, and the second concept is the main general concept, which is actually if the number of atoms will be n, then it will be in the close packing is equal to n, then it will be for octahedral void is equal to n, then tetrahedral void is equal to twice n. Okay, and by using actually these two concepts, we're going to do any types of question. Let's suppose, again we can take another example. Okay, so suppose an ionic solid has let's suppose 2 elements A and B. Okay, here if the atom B will going to, or let's suppose A will going to form that packing structure. Let's suppose the atom A will going to, or element A will going to make that packing structure. Then it will be what? Then it will be your anion. Understand? Anion. Okay. Again, let's suppose it is given that the B will be inside that octahedral void only. All the octahedral voids only. Okay, all the octahedral voids only. So it will be what? All octahedral voids means, that means we know that if the anion, number of anion is equal to n, let's suppose the number of anion is equal to capital N, then the number of B will be also capital N, because number of octahedral voids is equal to the number of anions. That means the packing structure, that means the total number of atoms. Okay, understand, no? So that means your structure will be, or your formula will be AN BN. Okay, that means AB. If you multiply it by 1 by n, then you will going to get AB. So the formula of the compound will be AB. So if they additionally ask you the nature of B, so what is the nature of B? Is it big? Is it big in size? Big in size? Is it big in size? Or is it small? But the thing is that this is cation, no doubt cation. Okay, but the size of this one is what? Is it bigger? Yes, it is bigger, because it is only occupying the octahedral void. You see, understand? Because it is occupy only octahedral voids, that means the size of the cation is slightly bigger. Okay, not as big as the anion, because the size of anions are always bigger. Okay, because this is already discussed in the previous class. Okay, so that means we can, from this problem 2, we able to understood that we can find find the formula of any solid by using this 3 techniques and this concept. Understand? Hope you understand this these numerical problems. And in the next class we're going to discuss about the most important part of this chapter, which is actually calculation of packing efficiency. Okay, it is very, very important for your exam. Okay.